Hello everyone, we are at Beyond the Formula. Let's see an interesting topic, that is, why does a cyclist lean while taking a turn? So you all must have seen that when a cyclist takes a turn, he or she bends towards the inner side of the turn, right? To maintain what? To maintain equilibrium, correct? Now is possible. This turn is possible due to the combination of resultant forces about friction force, gravitational force, etc. Right? So let's see why the cyclist take the turn or take the lean while taking a turn. So if you are going straight, right? If you are going, suppose this is the road, this is the roadway, and if the cyclist is going straight, right? If you see from the side view, you will see what? Cyclist, right? Now what happens in the straight scenario? This is straight, no turn, no lean, right? No turn and no lean. So what happens here is mg, this is the normal reaction, and this is the frictional force, and this is the, say, velocity v, right? F mu, frictional force, right? So due to friction, or with the help of friction, the cyclist moves forward, correct? Now when you take a turn, when the cyclist take a turn, so what happens? Suppose this is the turn, this is the turn of radius, say r, right? So what will happen here is, suppose if you are if you are going straight, if the cyclist is still going straight, the same scenario will happen, right? The same scenario will happen, only what will change? The friction force. Now the friction will be here, F mu. Now the friction will be here, F mu, towards the center. This is the, suppose, center of the turn, right? Center of turn. Now let's see through the diagram here. You see here, suppose for example, this is what? Center of mass. This is the center of mass of the body, cycle and cyclist, right? Now at this point, this is the point A. At this point, this is the point A. The frictional force, see this is the friction force F mu acting towards the center of the turn. This is the normal reaction, and we have mv square by r. This is the centrifugal force. This F mu will provide the centripetal force Fc, and this is the centrifugal force acting on the cyclist, right? So now you see, if the cyclist was straight, suppose the center of mass was here and the cyclist was here, correct? So only the F mu was acting towards the center. Now this F mu will be providing what? This is the distance from the center of mass, say, suppose r, right? Not r, we will use another, suppose d, right? So this F mu will provide what? A torque of F mu in anti-clockwise direction, right? We will use what? Nothing but d vector cross F vector, right? This is the torque that will be provided by frictional force. This will be anti-clockwise, and due to this anti-clockwise torque, the cyclist feels what? A force away from the center, right? So to overcome this torque, to overcome this torque, the cyclist takes a lean, and this lean makes what you see here now. You see, this is the center of mass. This is the center of mass and mg. Now this F was providing torque, right? This distance d, and torque, say anti-clockwise, ACW, was what? D times F mu, right? Now this center of mass mg, this weight mg, suppose this distance is say a. Now this weight mg, due to this weight, due to this weight, the torque about point A, will be clockwise. The torque about point A, the torque of mg becomes mg times A, which is clockwise torque, and this will overcome this torque, and hence when torque of ACW, that is anti-clockwise torque, becomes equal to torque of mg, that is the clockwise torque, what happens? Equilibrium is achieved, and the cyclists do not fall, and this is the reason why they lean, correct? Now let's move back. So we have seen here, what? Suppose let's draw diagram. So this was point A, right? That was the bicycle tire. This was point C, and the lean angle was theta. This is the point C, and suppose this is the point B, correct? Now this was the mg, and this was centrifugal force, that was mv square over r, where r is the radius, and this was frictional force, correct? Okay. Now you see, we have torque, of mg, that is minus mg times AB about point A, correct? And we have torque of F, that is friction, that will provide what? F mu times, that will provide the necessary centripetal force, which will be equal to what? Nothing but mv square by r, which is nothing but mv square by r. So we have mv square over r times what? BC, that is about point C, correct? So we have both the torque balancing. So we have tau net equals 0. So to maintain the rotational equilibrium, torque net, or the net torque acting, should be 0 on the system. So we have mv square over r. Now you see BC, this is BC. Now BC can be written as AC, this is what? Nothing but AC sin theta, right? And AB can be written as AC cos theta, correct? So we have mb square over r times ac sin theta equals mg times equals mg times ac cos theta, right? So we have ac cancel out ac, m cancel out m, so we have v square equals what? Gr cos theta over sin theta, right? So we can write rg cot theta equals v square. Now you see we have taken this angle as theta, right? The angle with the horizontal as theta, right? Now if you take this angle as alpha, this will become 90 minus alpha, right? 90 minus alpha is nothing but theta. So the equation becomes as what? V square equals rg cot 90 minus alpha, which is nothing but rg tan alpha, right? V square. So we have tan alpha equals v square over rg, or alpha equals tan inverse v square over rg, where r is what? Where r is the radius of the turn and v is velocity of cyclist, right? And gs 9.8 meter per second square, that is acceleration due to gravity, correct? So what happens here is, what happens? Cyclist bends to maintain what? Rotational equilibrium. Cyclist bend to maintain what? Rotational equilibrium. The gravitational force causes clockwise torque, sorry. The gravitational force, that is the mg creates clockwise torque, and the centrifugal force mv square by r, that is provided by friction, of course, creates anti-clockwise torque. And so these two forces, these two torques are equal in magnitude, so cancel out each other and creates the rotational equilibrium and helps the cyclist to take a safe turn, correct? So this is all about the cyclist taking a lean while taking turn. Thanks.